It should not come as a surprise that we are still learning new information about the interior of the Earth, given how difficult it is to investigate. It is becoming less difficult as new technologies are developed, and this has prompted researchers to unearth some previously unknown critical features about it. A recent examination of the inside of the Earth hints at the existence of a thick iron ball at the very center of our planet that may be another inner core within the existing inner core. This may shed light on some previously unknown facts regarding the history of Earth's genesis and evolution, pointing to a huge global event that took place early on in the history of our planet. From the crust all the way down to the core, the inner structure of the Earth is made up of a succession of concentric layers. The inner core is the densest section of our planet. It is a solid ball primarily made of iron and nickel and comprises less than 1% of the volume of the Earth. It is located at the very center of our planet and has a radius of approximately 1,200 kilometers. This inner core is similar to a time capsule, as it contains the history of Earth. Convection in the outer liquid core is driven by the release of heat and light from the solidification process, which occurs as the inner core grows larger. This is the motor that provides the power for the dynamo, which is responsible for converting kinetic energy into magnetic energy and maintaining the Earth's global magnetic field. It is believed that this magnetic field prevents potentially dangerous radiation from entering the atmosphere while allowing life to flourish within it. Alterations in the inner core could therefore cause alterations in the dynamo, which could have ramifications for the habitability of Earth over the course of geologic time. But researching the interior is not an easy task. We are forced to rely on seismic waves that travel about the interior of the globe, undergoing transformations when they come into contact with volumes of differing densities. We are unable to just go down there and drill into it. A little over 20 years ago, scientists discovered evidence of a second, smaller inner core located within the larger inner core. They referred to it as the deepest inner core, and additional investigations have supported its presence. But learning more about it has remained challenging, in part because it is buried by so many other layers, and in part because it can be difficult to place seismic stations in the correct areas. But the number of global seismic monitoring stations around the globe is continuing to expand, and they are detecting the barely detectable shaking of the planet beneath our feet more and more frequently. And now, because of the work of some brilliant seismologists, we know how to extract information about the planet's innermost core from those records. The specialists explained their findings in a publication by stating that their investigation makes use of the constantly expanding global seismograph network to generate global stacks for select notable seismic occurrences separately. This paper reports on a class of seismological observations of echoing waves across the mass of the Earth throughout its circumference up to 5 times that have not been detected or utilized before. In the seismological literature, reverberations from more than 2 passages have not been observed up until this point, as far as we are aware. When a massive earthquake shakes the Earth, the resulting event creates waves that move throughout the world, passing through the structures that are there and ricocheting off of them. This is how scientists have been able to construct such an accurate map of the inside of the Earth. The seismic waves, however, are deflected whenever they come into contact with a boundary. A reverberation, in contrast to an echo caused by an earthquake, is significantly less intense. Until this discovery, scientists had never reported more than 2 separate instances of the seismic event passing around the Earth. Experts were able to break this record by accumulating the data and combining a number of seismic signals into a single trace in order to enhance the signal from multiple big seismic occurrences. This allowed them to surpass the previous record. They were able to conduct a more in-depth investigation of the planet's inner core as a result of their discovery of 3, 4, and 5-fold seismic reverberations, which they discovered for the first time. Due to the fact that distinct pairs of waves traveled at different speeds, it was deduced that the planet has a very thick inner core that is around 404 miles across but no broader. It is possible that this structure was formed as a consequence of a significant shift in the rate of expansion of the inner core at some point in Earth's history. The findings of the research indicate that we now have sufficient proof of the existence of the deepest inner core, and that future work should concentrate on describing it, along with the outermost inner core and the boundary between the two. In addition, it indicates that the data may already contain the answers that we are looking for and are just waiting for someone to find them. The findings that have been published here are a consequence of the unprecedentedly expanding volume of digital waveform data. It is hoped that these findings will motivate the additional study of existing seismic records in the hopes of identifying hidden signals that shed light on the Earth's deep interior.